Hey, welcome back, you crazy cats. Today we're going to be going over gravity and learning some information about it. First of all, we're going to learn about gravity as an acceleration. We're going to learn what the actual number for gravity is. We're going to learn about objects falling in a vacuum, and we're going to learn about the 4 alterations that we make to our kinematic equation specifically for gravity. The first thing we're going to talk about then is that gravity is 9.81 meters or 9.8 meters per second squared. It's actually negative, and I've added this negative to it. And the reason we say it's negative is because it's going to be going down. Specifically, gravity is this when we take away air resistance. Speaking of air resistance, we know that in everyday life that if I were to drop a feather and a dime or a quarter or any coin, that the feather and the coin are not going to drop at the same rate. The feather has much more air resistance, so they do not fall side by side. The coin has less air resistance and it drops much faster. But if we were to suck out all of the air so that we no longer had that air resistance, both the coin and the feather would fall side by side. And we call this a vacuum. Okay, let's talk about some adjustments we make to our kinematic equations using gravity. So gravity is an acceleration. So essentially now what we're going to do is we're going to replace all of the A's with G's. And then the other alteration, which is fairly simple as well, is instead of using X's, we're going to use Y's. Okay, let's look at some problems here. A rock is dropped straight down from a window that is 40 meters upward. What is the maximum speed reached by the rock? Well, before I do anything, I'm going to make a list of the information that's happening here. It's dropped straight down from a window that is 40 meters upward. So I'm going to say that yi is 40 meters. What's pulling on it? Well, gravity is pulling on it at negative 9.8 meters per second squared. YF, well, it says what is the maximum speed reached by the rock? Well, that's going to be right before it hits ground. So YF, I'm going to say, is 0 meters. We've got that. I can say that the initial speed in the Y direction, all right, if it's dropped, is 0 meters per second squared, and we want to find VF in the Y direction. So let's go over and look at our equations here. I want to find VFs. So this first one here isn't going to do me any good. No VF. Oh, there is. Sorry, I don't know. I'm used to VF. I'm VI, VF. There we go. So I do know VI. That's 0. What's pulling on it? Gravity. I know that, but I don't know time. I don't know VF. I can't solve for 2 variables. So I'm going to say that equation 1 doesn't do me any good. Let's go to equation 2. This is my VI. But there's no VF in this equation, so I could probably solve for it, maybe, maybe not, but it's not going to give me what I need. So I'm going to go to the next one here then. All right, this is my VF, there's my VI, so I got VF, I have a VI, I know gravity, I know my final height, I know my initial height, ding, 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 I have my winner here. Equation 3 becomes my winner for what I want to find. So, find a spot I can write this here. It's kind of hard to write. VF squared equals VI squared plus 2G, and then it's going to be YF minus YI. So now it's just a matter of putting in what I know. VF is what I want to find. VI is initially, VI is 0, so I'm just going to go ahead and cross that out of the equation. 2G, so that's 2 times negative 9.8. YF minus YI. Well, YF is 0. YI is 40, so I'm going to get rid of my YF because it's just 0 minus 40, or negative 40. So now I'm going to use my calculator a little bit here to simplify this. 2 times negative 9.8 times negative 40. And I get VF squared equals 784. Take the square root of both sides. and we get a final velocity then of 28 meters per second. So what is the maximum speed reached by the rock? 28 meters per second. A rock is thrown down from a window with a speed of 5 meters per second. When it hits the ground, it is traveling 55 meters per second. What is the distance the rock fell? Well, we have, again, we know that VI, I had to read it real quick there again, 5 meters per second. VF is 55 meters per second. I know that YF, the final height, is going to be 0 meters. They want me to find YI. I know that gravity is negative 9.8 meters per second squared. Well, again here, let's go through our, they want me to find YI. Well, the first equation doesn't have YI in it. The second equation does have YI. Alright, I know YI. I know, oh sorry, I know YF is 0. They want me to find YI. I know the initial velocity. Time, there's the problem. I don't know time. I don't have any times. So I can't use equation 2. VF is 55. VI is 5. I know gravity. I know the final height is 0. Here's my variable I do not know. So equation 3 happens to be the one I'm choosing here again. VF squared equals VI squared plus 2G YF minus YI. 55 squared equals 5 squared plus negative, and I know that 2 times 9.8 is 19.6, so you're going to see me quite often just go ahead and put negative 19.6 there. YF is 0, so I'm going to get rid of that, minus YI, which is what I want. Because 0 minus YI is just YI. From here now, I'm going to use my calculator and simplify some things here. This gives me 3,025 minus 25, or equals 25, not minus, plus negative 19.6 times negative YI, so my negatives are going to cancel out. Now it's just a matter of doing some simple algebra here. Subtract 25 from both sides. I'm going to bring it down here. 3,000 equals 19.6 YI. Divide by that 19.6. Hey, and we get a YI that is equal to 153 meters. Hey, sports fans, today we found out about gravity. We talked about the acceleration of the gravity. How do items fall in a vacuum? And what are the alterations to the 4 kinematic equations for gravity? These should be 4 questions that you answer. I'll catch you guys on the flip side.